Thanks for the invitation, and it's been really wonderful hearing all these presentations. So this is extremely time constrained, so I'm going to go very fast. It's a 30,000 foot flyover, so let's get started here. This is a website. These sheets will be distributed, I assume. And this is a website where you can link to all of the publications and blogs and other things and software. And if you look down at the very bottom, there's expert judgment data, over 100 professional cases that have been financed and with review committees and all of that published. You can find that raw data here. Okay, next. Yes, this is a course offered at the TU Delft on structured expert judgment. It is free. It's designed and run by Tina Nan, who is a professor there, who's now dealing with up for 3 years, and she has had something like 7,000 participants. So it's a groundswell that is building here, and you are invited to explore this and take this course, or better yet, let your students take the course and see what you can learn in that way. Okay, next please. This is the most important sheet of my whole talk. If we don't get any farther than this, I will have accomplished the objectives. So I'm going to go through this more slowly. What I've done is taken 6 studies, starting in the upper left with the ice sheet study from Princeton University, which was recently published in PNAS. Then the next in the middle on the top is the fine particulate matter study from Harvard and the Kuwait government. Then the next on the right on the top is foodborne illnesses from CDC. And then on the bottom, we have IQ and earnings for the Gates Foundation. We have Asian carp invasion and GDP and oil. Now, from each study, I've taken one of our calibration variables. These are variables from the expert fields to which the true values are known. And this is the centerpiece and most important aspect of expert judgment. It's, after all, just you compare it with the truth. Then finally, you know sort of what you're talking about. So for each study, I have, well, actually, I have 4 variables from each study. I said 1 variable, 4 variables. And if we look at the foodborne illness study, for each variable, we have a number of experts. Each expert assesses a 5%, a median, and a 95% value. Those are indicated by these horizontal lines. The median is that little black dot. And for each calibration variable, we also have the true value, which is given as a red vertical line. So here you see the good and the bad and ugly of expert judgment. So click, please. If we go to the bottom right, click, bottom right. Yes, there we see an expert who has high information and low statistical accuracy. So on these 4 calibration variables, you see that his 90% confidence band fails to catch the true value on all 4 cases. Now, he might be having a bad day, but probability will tell us how to measure exactly how bad that day was. Another phenomenon is on the lower left, that's good statistical accuracy. So an expert has rather wide confidence bands, and he catches the true variable with the proper frequencies, but he's not very informative. Now, the upper left variable shows the Goldilocks expert who has both high statistical accuracy and high information. And this is what we like to see. We don't always find Mr. or Mrs. Goldilocks in our expert panel, and therefore we have to combine our experts. So click, one more time, click. There we see the combination of expert judgment and performance, but also based just on equal weighting. So what we typically see is that the equal weighting combination is rather uninformative, tends to be statistically okay, but uninformative. And the performance-based combination, where we assign experts weight based on their performance on the calibration variables, that tends to be statistically accurate, but also more informative than equal weighting. So that's the long and the short of structured expert judgment. How we do all of that, you can find in that supporting literature. Now I'm going to show you the results from one getting a lot of play. This was a study of 22 experts assessing the impact of ice sheets on sea level rise out to 2300. And what I'm showing you here are the assessments of the sea level rise from ice sheets in centimeters in the year 2300 based on a stabilization scenario. And on the left, we see 8 experts. These are not all 22, but I've taken the 8 experts who were the most statistically accurate. And you see that their views are quite dispersed. And you will also see, if you look at 100 and minus 100 centimeters, that's the zero line. So many experts anticipate that there is a small chance that the sea level rise due to ice sheets will actually be negative. That is to say, the ice sheets will in fact grow, and you can find physical scenarios in which that will happen. It's not likely, but it is possible. So it's part of the uncertainty. Most of them regard that the upper 95% band is pretty high. This expert number 1, 2, 3, 4, 5, you see, fifth value is 15 meters, 15 meters. So he's going basically from 0 to 15 meters. Now, if you combine these experts, those are the 3 distributions on the right, where we have equal weight combination. We have a combination based on performance weights, where we look only at the experts who are statistically accurate. And then we look at an optimal performance weighted combination. And so what you see is that by using performance weights, you can get a more informative distribution without sacrificing statistical accuracy. And if I, go to the next, there we go. So this is from the IPCC's 5th assessment report on the sea level rise as a result of thermal expansions, glaciers melting, and the ice sheets melting in Greenland and Antarctica. Now this sort of a brown, if we look at 2300, that's in the middle, and we look at this brown line, this is the uncertainty from the full model spread, as they call it. That typically represents the 17th to the 83rd percentile of the distribution that IPCC gives for the uncertainty. So I want to compare that. Now click. That is the distribution of the 90% confidence interval from our structured expert judgment study. So I claim that this is a very different story about the uncertainty. And you see, it's possible that the ice sheets will actually grow and hence reduce the sea level rise, but it's also equally possible that they will contribute to sea level rise by at least 10 meters. So we are getting a much different picture of the uncertainty. And in contrast to the other things, this is based on methods that are empirically validated to the extent that we can do that. We have a large data set of expert judgment studies, and in this data set, we include a large number of calibration variables. And as Anke said, I think this is the only data set in the world where you can actually compare what the experts say. I would assess that these calibration variables are all variables from the expert field, which are defined in consultation with the oversight committees that are in charge of the study and so forth. So these are highly vetted calibration variables as being appropriate for the study at hand. We have 530 experts. Each expert assesses roughly 10 to 15 calibration variables. So we have 49 studies that are post-2006. We have a similar number that are pre-2006, but our efforts lay on the post-2006 studies. We have already published stuff on the earlier studies. So this is from an article in the International Journal of Forecasting, and we analyze this in all sorts of ways. But now what I'm showing you now is the effect of quantifying uncertainty versus not quantifying uncertainty. So suppose we asked experts only for their best guess. What is your best guess? And then we average their best guesses. That gives us the red histogram here, which is called average of medians. So what we are showing is a scale invariant measure of accuracy. It's the point value forecast minus the realization divided by the realization. So we're getting rid of the physical dimension of each variable. And what we see here is that if we take a performance-weighted combination of our experts and we extract the median values from those performance-weighted assessments, and then we look at how close we are to the realization, you see the histogram of the blue lines here. If we just take their best estimates and average them, of the red lines. If we take an equal weighted assessment, an equal weighted combination of all of the expert assessments, we get the green lines. Okay, so this is an important point. Let me pause by this thing for a second. Averaging the medians is not the same as taking the median of the average of the distribution. I repeat, averaging the medians is not the same as taking the median of the average of distributions. Okay? And of all the methods that we have explored, just average best guesses is far and away the worst. And so you see in this histogram, you can look at this in detail at your leisure, but the table at the bottom really just gives you the punchline. If I take the performance weighted combinations and I extract the medians from those performance weighted combinations, and I compare that median with the realization, and I do that for all 580 calibration variables, I see a standardized error of 2.2. So that is to say, the average deviation between the realization and the performance divided by the realization is 2.2. If I take the average of medians and I look at that standardized error, it's 1,514. I mean, it's way, way off the map. If I look at the standard deviation, that is to say the spread in these errors, with the performance weighted combination, the standard deviation is 12. With the average of medians, it's 33,778. So it's like really, really bad, right? And yet that is what most expert judgment studies that are out there that I've seen will do. They will just take the best guesses and average them at your peril, is what the sheet is showing. Okay, there's a lot more in that article, and I will just mention that we spent a lot of time studying the claim that the differences in expert performances were just noise. And I'm not going to discuss that here, but we spent a lot of time studying that, and the answer is they are not. Can I go back one sheet? Yes. What we also have done is out of sample validation. So what we do is we
Roger, we are just gonna pass the timing, but I mean you can just conclude and please.
All right, I conclude. It's all there for you.
Thank you very much, Roger. Sorry for interruption. Just making sure that we will have kind of time to discuss. And thank you very much.
I completely approve.
For such a really nice presentation. And thank you very much.